Voltage and generator. I seem to leave out, that's okay. Voltage and generator for Faraday's law. Hopefully you know Faraday's law by now. EMF equals minus D, change in flux over dt. Now, we already worked out the voltage in a generator, and if you haven't seen that video, check it out. Just using Lorentz force law, we did the V equals BLV, and we were able to calculate a formula which went like this. V equals Born, and then sine omega t. So that was cool. Now what we're going to do is show that this can be worked out using Faraday's law and the rate of change of flux. They're really the same thing, they're just different ways of looking at it. And so if we're looking at rate of change of flux, then what we're looking at there is, well, flux, as you know, is BA. In this case, the magnetic field is staying constant, so d flux dt is just B dA dt, right? Now, how can we characterize the area, and where do we measure the angle from? And when we did this one, we measured the angle from the vertical, remember? The angle of the coil. So this coil right now would be at 90 degrees based on the way we were measuring it. And so the area is the area through which the flux is changing. So at 90 degrees, if the area is 0, which it is, and if at 0 degrees the area is maximum, then we can say that the area can be characterized by a Cole's graph, because at 90 degrees it's 0, and at 0 degrees it's maximum. So we can say the area is equal to A cos omega t, omega t just being the angle. So we actually can write this formula now as E equals minus B A D cos omega t dt. So we're just about there, aren't we? Now all we need to say is that take the derivative of cos omega t, and cos, well, sine goes to a cos goes to a minus sine times a minus is a plus. So we've got E equals BA sine omega t. BA sine omega t. And let's not forget, when we do the derivative of omega t, we need to take the omega out. So we've got another little omega there, and we're starting to look good. So I think we can already see that our formula is coming along. B A omega sine omega t, and the n is just for more than one term. And we've got the same formula. We've done it with Lorentz force law, V equals BLV, which we derived, and now we've done it with Faraday's clever little law.